Good afternoon to all dear participants. Myself, Dr. Tejas Shah, Assistant Professor at Ambaba Commerce College, Sabargam. I welcome to all at online FDP on research methodology jointly organized by MHRD Department, VNSGU Surat, and jointly organized with JZ Shah Arts and HP Desai Commerce College, Amroli, Surat. I am also thankful to Principal Dr. R.D. Rana sir to give me this kind of opportunity to introduce today's resource person. Today is the fourth day of online FDP. I give some brief introduction about the today's resource person, sir, C.S. Sarma sir. C.S. Sarma sir had a wide experience experience of 40 years in India and overseas in teaching, program development, and institution building, financial performance, and business development. Sir has also published books and 47 11 books and 47 research paper with the different types of topics in commerce and interdisciplinary subjects. Hello, my voice is clear, audible?
Yes.
Yeah, okay. Uh, Sir has supervised research at IIT Delhi, Department of Commerce, University of Delhi, Amity University, and has acted and is a sought after a speaker, notably in research methodology, including quantitative research, human behavior in finance. Currently, Sir is a professor in Department of Commerce, a well-known Srinam College of Commerce. Earlier, Sir was a director at Maharaja Agrasen Institute of Management, Studies and JRE Group of Institutions. Sir has also conducted more than 200 workshops and trainings program at institutions like Punjab Police Academy, Ramanujan College DU, various colleges, and month-long a resident all India faculty induction program conducted by Teaching Learning Center sponsored by the Ministry of Education and Ramanujan College of University of Delhi. Sir is the coordinator of IQSC at SRCC, in charge of value-added courses and institutional collaborations, and look after the National Resources Center, Commerce Discipline, sponsored by Ministry of Education at SRCC, which offers online faculty development program covering all four quadrants. Uh, Sir has a vast experience and book publications and maximum 200 workshops are already done by the sir. Sir, uh, I have given a brief introduction. Hello, Sarma sir, can you hear my
Yeah.
voice?
Yes,
Yeah,
I can hear.
okay. Thank you. And I welcome to you, sir, from on behalf of Amroli College. Sir will start the today's topic, univariate, bivariate, and multivariate analysis. Okay, now over to you, sir.
Good afternoon, Professor Tejas Shah,
Yes, sir.
the administrator at Amroli College. I
Yeah,
think this is what your college is. And am I audible? Am I audible clearly?
clear, sir.
There is no surrounding sound or echo coming?
Exact clear voice.
All right, fair, fine. So, and dear participants, it is a, first of all, thank you very much for giving such a generous introduction to me. But it is my great pleasure that you have invited me to address such a large gathering on this topic of univariate, bivariate, and multivariate analysis. I had a discussion with Mr. Dr. Bhavesh in the morning today, and I'm told that you have audience from across the country and also from distant countries like Vietnam, Australia, and so many other countries of the world. It is very nice, and I think research methodology is a very important topic for the purposes of honing our skills as academics for data analysis purposes. Now, before I really proceed on the discussion on this topic of univariate, bivariate, and multivariate analysis, let me just outline what really I wish to discuss in this particular, under this heading. First is, I shall like to discuss, while discussing the univariate analysis, when we talk of univariate, bivariate, and multivariate analysis, univariate means analysis of a single variable. Bivariate means analysis of two variables. I'm only translating, I'm just putting English, it is English translation or re-explanation of the terms. And multivariate analysis means that analysis of multiple variables. Now, when I want to discuss this in terms of the following. Number one, when we are discussing a single variable, first of all, I shall like to take up what do we mean by a variable. I'm sure in the last 3 days' time, and otherwise also the learned audience would have known the meaning of this term, but just as a refresher, I would like to remind you, or maybe remind myself, of what a variable is. And then we shall look at some of the fallacies in the analysis of univariate variables. And then we shall look at, after those fallacies, I shall like to discuss the reductionist idea of analyzing or employing univariate variables. After that, I will go over to discuss the bivariate analysis. And within the bivariate analysis, I shall discuss subtle aspects or important aspects of regression, correlation, subtle aspects or important aspects of regression, correlation, and some of the, basically, some ideas, if the time permits, of the use of qualitative dependent variables, how we analyze them, what happens to the simple regression. That is, I would like to speak a little about the utility of logic regression and calculation of logic regression, basic thrust of logic regression, if the time permits, in the bivariate analysis. Lastly, I shall like to discuss in the multivariate analysis, using the Ballantine approach, I shall like to discuss the role of semi-partial correlation and partial correlation in analyzing the data, which often is ignored in the analysis. This is the basic structure of my lecture, my dear friends. So let us first begin with the idea of what a variable is. Now, as far as I'm sure the participants would be knowing the meaning of the word variable, variable actually is collection of attributes. That is what basically a variable is, my dear friends. We start with essentially the thought of an attribute. Essentially, we start with a quality. Since I was told that we are addressing the students relating to, or the scholars and the professors who are in the field of commerce and management, so I shall like to focus essentially on that only, my dear friends. So first aspect that I shall like to discuss over here is the concept of attribute. Now, what actually is an attribute? Attribute is a quality which is either present or it is absent. For example, being a male or a female. And second aspect of this is, associated aspect of this is that there must be an element of mutual exclusivity in the description of the attribute. So we would say male or a female is an attribute. Your place of residence, you live in urban area or you say live in rural area. Now, being an urbanite in itself is an attribute, and it is mutually exclusive. Because if you're an urbanite, if you belong to urban area, it means you are not belonging to any other category. So essentially, attribute happens to become a categorical phenomenon. Either it is there or it is not there. Now, variable, in contrast, we will say that a variable would be a logical set of attributes. I repeat, variable is logical set of attributes. Variables are logical sets of attributes. Set. When we say logical set, word set here means that there are elements in it. That is to say, if we say, for example, being a female is an attribute. Being a male is an attribute. Being a transgender is an attribute. But if I combine these all together and I say gender, now gender will consist of male, a set of attributes which will together combine and make this a variable. Now, why I am talking about this, my dear friends? When we are talking of univariate, bivariate, and multivariate analysis, it means we are committing ourselves philosophically to the positivist approach to research. And what is positivist approach to research? Positivist, there are two approaches. One is positivist approach to research, and the other is interpretivist approach to research. Interpretivist approach is essentially qualitative research. Positivist approach is quantitative research. In the positivist approach, we always assume that, very important point that I'm making here, observation and measurement. There has to be an observation, there has to be a measurement of the phenomenon that you are studying. And in positivist approach, when we adopt positivist approach, then as a researcher, we take a stance, a philosophical stance, that something which cannot be measured does not exist. If you have to study something, it must be measured. It must be measurable. And what is measurable? The measurable has to be the phenomenon, and the phenomenon has to be examined through the variables. And what are variables? Variables are logical sets of attributes. For example, if I say gender, so gender would consist of the logical sets of attributes, logical sets of qualities that would constitute together the variable called gender. And it must have the variable, your variable, when you are studying a phenomenon, must satisfy two conditions, my dear friends. First condition is that it should be exhaustive. Exhaustive means what? That the variable must consist of all possible elements, all possible logical constituents, all possible logical attributes composing that particular variable. For example, when I say I am studying gender as a variable, then I must cover all possibilities, all qualities that can constitute a gender. So I would include male, female, transgender, or third gender. Or if you like, you may add something more to it if you want. If you have logic behind this, logic behind your own study. If there is literature available, that literature should be able to justify the constituents of that particular variable. For example, if you are studying the concept of, say, trust as a variable, then trust is a single variable undoubtedly. But it must be constituted by the exhaustive, that is, complete list of all constituents of trust, such as, say, for example, we can say reliability. A person has to be reliable to be trustworthy. A person must keep promises to be reliable, to be trustworthy. A person should be available for assistance. In work environment, a trustworthy person is one who has necessary skill to perform the job, and so on. You can have a list. For example, you are studying a variable called love. Then what will constitute love? So maybe you will say the attributes like romantic love, motherly love, fatherly love, friendly love, love of a friend. And they can have subparts within them also. So as per literature, we have to, when we are talking of a single variable, or we are talking of multiple variable, we are talking of univariate analysis, bivariate analysis, multivariate analysis. So essentially it is analysis of a single variable, analysis of two variables, analysis of multiple variables. So we should be clear about what a variable really is. And in the research process, the first thing is that your variable must be well and clearly defined. And how it should be defined? First aspect, that it should have logical sets of attributes which are exhaustive. All possible aspects are covered by you, and it should be justified logically why it is being included. And sometimes, if you are doing research, it is not possible in social sciences to cover all possible attributes in the research. So you must give reason why others are being excluded. First aspect, therefore, what is a variable? Variable is logical sets of attributes, and they must have two qualities. First, I told you, it should have exhaustive. The list of attributes should be exhaustive first. And number two, the attributes that you are including within the variable, those attributes must be mutually exclusive. For example, if our variable is gender, and within gender you are including male, female, and transgender, then A person who is male cannot be classified as female. A person who is classified as female cannot be classified as transgender or male. And a person who is transgender cannot be classified as female or male. So this kind of mutual exclusivity has to be there to have a good definition of a variable, my dear friends. So this is first aspect that we should be clear about when we go on to discuss the univariate, bivariate, and multivariate analysis. Let us be clear, we should be clear about the meaning of the term variable. This is first aspect. The second aspect relates to the measurement of these. And I'm sure the measurement has been covered with you. If I can assume this, that there are 4 types of measurability. One is nominal measurement. Second is ordinal measurement. Third is interval measurement. And fourth is ratio level measurement. Can I, at this point, ask my audience to quickly say, do I need to explain the level of measurements or I proceed? You can write in the chat box, please. I hope Mr. Shah, Mr. Tejas Shah, is it okay for me to ask this?
Yes, sir.
So quickly, please, dear
Yes,
friends.
sir. Yes.
I want to know, do you want me to explain this or I proceed? Can I assume? Yes, sir, please explain. Yes, sir, you can brief. Proceed, sir. You can proceed, sir. We are getting both the answers. I can proceed, and some are saying, please explain in brief. So are there any more responses, please? Please write down. I have had only 4 responses so far, 4 or 5 responses.
Yes, participants,
it was discussed.
Yes, you can write down in the chat box.
Okay, explain in brief. Okay, explain in brief. Yeah. All right, very quickly I will explain. I will not take more than 2 minutes. For there are some people, let them be involved in this. Quickly I will do it, and those who know it, they can please bear with us. You see, I'll just take an example. Say, very simple example I'll take. Say, for example, I have with me a group of individuals I have, and I define them, say for example, in terms of age. Say 3-year-olds, say infants, I say infants, children, adolescents, then I say adults, and then I say senior citizens. I put them all together like this. Now, if I say that a person is, now this is, age is a variable here, and I'm defining this in this manner. Now, a person, if I'm putting as infant, obviously that person is either an infant or he or she is not an infant. If I'm studying only infants and non-infants, it is a nominal variable. A person is either a male or a female, for example. It is a nominal variable, presence or absence. Now, this is one. Now, if I order the age, if I put the age in an order, so for example, I put an age in order how? Infant, children, adolescents, say only 3 I am saying. Or say, for example, adults and senior citizens. Say these are the classifications which I have. Now, I do not define what is the difference between, that is, there is an order. Order in the sense that you start from infant, go to children, from children you go to adolescent, from adolescent you go to say adults, from adults you go to senior citizen. But what is the distance between them? That distance is not defined. That is undefined. But there is a classification, categorization. So this is called ordinal scale. We hear the data, if we are not defining the distance between the two, then it will become ordinal data. And thirdly, if we put an arbitrary point of origin, say 0, arbitrary, it is not like, for example, then it will become interval data. In interval data, what happens is that say, for example, let us take the case of IQ. Now, in case of IQ, there is nothing like there can be 0 IQ, but that 0 cannot be defined. It does not mean 0 does not mean complete absence of intelligence. Like in case of temperature, for example, we have 0 temperature. Now, 0 temperature does not mean absence of temperature. And when we measure temperature in degrees, from 0 we go to 2 degrees. From 2 degrees we go to 4 degrees. Now, please see, the point of origin, that is 0, it is arbitrary. It is not real 0. So, because it is not real 0, so 4 degrees Celsius is not double of 2 degrees Celsius. And similarly, -4 or -40 is not double of -20. 80 degrees Celsius is not double of 40 degrees Celsius. 60 degrees Celsius is not 3 times the 20 degrees Celsius, because there is a number which is assigned to the values going up and to the values going down, and there is an arbitrary 0 point. But that 0 point does not mean it is absent. For example, in case of IQ, we administer an IQ test and we find that the IQ test is giving us, say, 140 is the score on Eysenck scale. So 140 IQ does not mean that a person with 140 IQ and there is another person with 70 IQ. So the person with 140 IQ is twice as intelligent as the person with 70. No, we only say that people can be graded on this. That's all. So this is called interval scale, when the arbitrary 0 point is arbitrary. But if the 0 point is real 0, then it will become ratio level measurement. For example, if I am say for example, I said that age I defined for nominal scale in terms of infant or not being infant. You are adult or not adult, that is nominal. You are adolescent or you are not adolescent, that is nominal measurement. But I order them, I put them in an order without defining the distance between them. That is, what is the difference between infant and the child, between child and the adolescent and the adult and the senior citizen. I don't define it. So it is ordinal scale. That is, the distance between different categories is not specifically defined. But if I say the age ranges from 0 to 80, and I define where does the infant begin. 0 means what? Baby inside the womb, or the moment the child is born, time of birth. And from there up to, say, 2 years. From 2 years to 9 years or 12 years, I say it is child. I can define the way I want to define. I can categorize it. Then I say adolescent, from 13 years to, say, 18 years. 18 years to 60 years or 59 years, a person is adult. Then it is of 60 and above, it is senior citizen. Now here a point of 0 has been specifically defined. Wages, for example, from 0 onwards, ratio scale. So this is how a very, very simple definition. I've taken about 5 minutes instead of 2 minutes while describing this. But these are the measurements, my dear friends. And these levels of measurement are very important from the point of view of the analysis in this regard, my dear friends. What method you would employ for the purposes of analyzing the data, that will depend upon the kind of measurement you have. For example, if you are, say, for example, you are studying, uh, say, for example, you are studying the religious affiliation, for example. One example could be this. And you want to report, say, mean number of people, average number of people following a particular religion in a particular area. For example, say you are studying that. People with political affiliation, number of persons who are trustworthy in an organization, having high trust or low trust. Now, these are ordinal or nominal variables. We cannot describe them. We cannot analyze them using mean, because arithmetic mean assumes that the measurement is ratio level scale. That is, there is a specific point, 0, in that particular variable. It can non-exist. And the variable can be expressed in terms of a fraction. Now, religious affiliation cannot be expressed. If you say religious affiliation, and I define religious affiliation as being a Hindu, Muslim, Parsi, or say Jain, Baudd, and so on. If I say that, these are essentially, either it will be analyzed either depending on how you are looking at them. If you are looking as a complete variable, it can be ordinal as well as it can be nominal, presence or absence. Now, in such cases, mode will be a better measure rather than arithmetic mean. So that is why, dear friends, in this short time that I have with me, with a huge topic to be covered, I can only say that it is very necessary for you to pay attention to the fact what is the level of measurement of your data before you adopt a way of analyzing that particular phenomenon. So far, I have talked about two things. Number one, I spoke about attribute and meaning of variable as logical set of attributes, which are characterized by two things: that they should be attribute should be exhaustive and attribute should be mutually exclusive. Then I talked about level of measurement to highlight the point that before we undertake an analysis of variables, whether it is univariate, single variable, bivariate, two variables, or multivariables, we must pay attention to the level of variables, level of measurement, and analysis must be done keeping in mind what kind of measurement do you have of the variable. That is it. Second aspect, my dear friends, relates to what I would say, that when we are analyzing the data for a single variable, let me come to the univariate variable, then at that time, two things need to be paid attention to. The first thing is what we will call the two fallacies. Two fallacies need to be paid attention to. First fallacy is, which I would call always the ecological fallacy. I repeat the word, ecological fallacy. What is the word ecological fallacy here? Ecological fallacy is this. I give you a small example. Say, for example, in your study, you are examining, I am taking an example, very general example. I'm taking, say, voting patterns you are studying. Say, for example, and you gather data about a particular candidate. There is a lady candidate and a gentleman who are contesting in a particular constituency. Okay. And what you do, you gather data about the number of votes which are available to you in terms of booths. In India, we have booths. Booth 1, booth 2, suppose it is available. Election Commission gives you the data, assuming that you are able to have this data, about both the candidates. Candidate 1, you have data on booth 1, booth 2, booth 3, booth 4, booth 5, booth 6. Say there are 6 booths. And you have data about the number of votes polled by candidate number 1 and candidate number 2. Now what happens? That you collect some data from the census. You also gather the data that what is the composition of the population in terms of young people and old people. Say, this is possible. In each booth, you have data on number of votes polled. That is, person has won or lost. And you also have data on the composition of population, old or new, young. Now, what you find in that data, see, very interesting. You find in this data that the population, the booths in which young population was more, the lady candidate won. I repeat, lady candidate won. She gained victory over the male candidate wherever the population was young. And she lost in those areas where population was, there was higher degree of population of old people. And based on this, you arrive at a conclusion. Obvious conclusion will be, which is what you see on the television. Very often, people will conclude that the lady is preferred by the young voters and male candidate is preferred by old population. This actually, my dear friends, is an ecological fallacy. What is ecological fallacy here? We are studying voting pattern of the booths. And what we are not studying, that is, we are not studying the age factor. That age factor we have imposed on our data by, in our enthusiasm to seek explanations. We very often do it. That is, we bring in environmental variables, variables which are in the environment and which are perceived as influencing those. So when we make the single variable we are studying, that is the voting pattern booth-wise. And we have imposed on it a variable, an exogenous variable from outside, which is not a part of the variable which you are studying in univariate analysis, single variable analysis. Very often this kind of mistake is done. This is called, my dear friends, ecological fallacy. So in univariate analysis, we have to be very, very cautious and careful, my dear friends, about the ecological fallacy. Second aspect is also very important. In the second fallacy, we call this fallacy the reductionist fallacy. Reductionist. And actually, entire statistics is nothing about reduction. I will come to this from here, but we should be aware. Say, for example, you are studying behavior of the employees. When you are studying the behavior of the employees in an organization, what aspects do you really study? You will study aspects related to individual, that is psychological aspect. You will also study group behavior, that is group psychology. And when you study group norms, then it becomes sociological aspect. And when you go beyond groups, you go to the whole organization as a social unit, then the unit will become a sociological variable. Now, when you are studying these behaviors from psychological angle and we make generalizations, so we normally expect, we can normally expect that the employee behavior shall be influenced by economic variables, by sociological variables, by psychological variables, by economics are economic variable, by political variables. All these variables by the politics within the organization that will affect the behavior of the people. Now, we tend to study only one dimension of this because we know we are asked in our study to specify the objectives. And objectives should be such that we are able to form a hypothesis to achieve those objectives. Hypothesis, based on hypothesis, we decide our data and instruments. And instruments and data are numerical. They gather data in numerical terms. I hope I am able to explain the whole hierarchy to you. Objectives, hypothesis, instrument, and data. Numerical data. That is measurable data, measured data that is made available to us. We exercise on that basis. But when we are using this particular mode of exercising research, at that particular moment, what are we doing at philosophical level? We are studying only a particular dimension, either psychological or sociological or economic, and not all of them together. Because our objective is, our goal is to achieve the objectives of research. Similarly, say for example, we are in the business of making policy. You are making policy, or say recruitment policy, for example, you are making for an organization which is multinational. So when you are making a policy, recruitment policy or promotion policy for an organization which has its presence in several countries, can you do that on the basis of economic analysis of the sales, revenues, and costs? Or you should take into consideration the culture also? Or you should take into account the psychology of the people in different countries also? No, this question arises. Normally what we do is that it is not possible for us to consider all the variables at the same time, because the variables are so large in number. Therefore, what we do, we focus only on a few. So, but when we are focusing on a few, we are making generalizations on the basis of a few variables. So whatever conclusions that we arrive at, my dear friends, we have to interpret them with great caution, because our approach is essentially reductionist. This is the basic limitation of the reductionist approach. But coming now to statistics, this very reductionist approach can be taken as our strength also, my dear friends. And how it is the strength, I will explain to you in univariate analysis. How do we go about making the univariate analysis? The univariate analysis, I am sure, they have put it here. Maybe they want to refresh, the organizers wanted the audience to have a refresher on the univariate analysis. Single variable is to be analyzed, and this is done mostly with the help of what we call the descriptive statistics. And the first that comes to the mind right away is the measure of central tendency. And here you employ, what do you employ? Mean, median, mode. I mean, these are the geometric mean, harmonic mean also. But I would not talk of geometric mean and harmonic mean. Geometric mean undoubtedly is very, very important when you are discussing the returns of a stock. One specific example I'm saying, but let me talk about mean, median, mode. Within this also, I will pick up, say, mean, arithmetic mean. Assumption of the use of arithmetic mean is very clear that the data are ratio level data. And ratio level data are very simple. What is a ratio level data? A datum which can be described in terms of a ratio, which can be described in terms of an absolute origin, absolute point of zero, like a wage, like an age. Wage can be zero, theoretically. It can have a 0 point. And when we say wage level 1 and wage level 2, they can be expressed in terms of ratios of each other. So it is applicable. Now, the general description is this, my dear friends. Mean has a characteristic feature that it replaces the all original data variables. It has a feature of that. Now, here, Dr. Shah, can I make use of a screen here? Is it possible?
Yes, sir. Yes, sir.
Okay, fine. I will quickly make use of this particular thing here. I'll just take a small example. Say, for example, your variable x is here, and it has 3 variables in it, say, and their value is 3, 6, and 9. And I hope this is visible, sir. My screen is visible. Dr. Shah? Is my screen
visible to all of? Yes, visible to all of you.
All right. So 3, 6, 9 is there. And say our total, we will say the total, I'm taking very, very elementary kind of example here. Sigma x is 18, and we say our n is 3, and our mean here is 6. Now, mean has a very specific property here, that mean replaces original variables. So if mean replaces original variables, if I am using mean, the moment I'm saying mean, now please notice here, replacement, 6, 6, 6 will also give me 18, and as a result of this, it is this. So what we normally say, we say once you have the arithmetic mean with you, you can throw the entire data into the ocean. But because mean replaces original values, but at the same time, we also say one thing about mean. We say that mean must be accompanied by standard deviation. And what is standard deviation? In a standard deviation, we take deviations from mean, x minus x bar, and we have to take the average of this. But some of the deviation, if we say x minus x bar, like here, if I say x minus x bar, and I say 3 minus 6, 6 minus 6, and 9 minus 6. So this comes to minus 3, 0, and 3. The total here will come to, this total is 0. And deviations cannot be averaged. So what do we do as a measure? We take the square of this, and then we average it out. We say we take x minus x bar squared, and we take it at 909. It becomes 18, and we take this as the average of this, assuming that this is biased. statistically biased. I'm not going into that. And to eliminate the impact of this squaring, we take a root simply. So we do this and we get the standard deviation. And this will give us root of 6, and this will be equal to 2.44. So we say now, see the reductionist analysis. Reductionist analysis is this 369 has no meaning now. The original data has no meaning because I know that X bar is 6 and the standard deviation is 2.44, which means my variance is 6. That's it, my dear friends. And here, what is very interesting point? Here is very interesting phenomena. The interesting phenomena in the univariate analysis is, please note my sentence. I'm repeating it again, and yet again. And my point is that the information which is contained in mean and standard deviation is more than the information contained in individual data points. Please note, I have made a statement. I made a statement that once you have mean and standard deviation with you, you have reduced entire data into two figures, mean and standard deviation. Rest of the information you can just throw into the ocean. And we can make analysis based on this. We know our data has to be number one, ratio level data. And we also assume one thing, that it is normally distributed, my dear friends. And once we say it is normally distributed, so we have the probability distribution of the data available to us because of the properties of mean and standard deviation. And what is the area property? I'm sure each one of you knows that 99% of the values lie between plus minus 3 standard deviation. That is, mean plus 3 standard deviation covers the 99% of the variable, and now we have probabilistic data with us. The probabilistic data set is that the probability that any randomly selected value will lie between mean plus minus 3 standard deviation. That is 6 plus minus 2 plus minus 3 multiplied by 2.44, which means 6 plus minus, we would say, 7.32, which means what? That 13.32 is one side and minus 1.32 is another side. That means 99% of the values are going to lie in this. In terms of estimation, therefore, it provides a huge role. This is what the power of univariate analysis is, provided your assumptions are correct. Ratio level variable is there. It is normally distributed. As my example, of course, belongs to only 3 observations. Only 3 observations. We ought to have large number of variables. And if we have large number of observations, and if we have large number of observations, my dear friends, then we are able to arrive at the analysis in a very robust manner. This is all I wanted to make. This is one point that I wanted to make in front of you, that the moment we move towards, once we have the data with us and we start examining the data, then if the assumptions that we are making about the information, about the data, those are correct, then the number of observations, the large chunk of data that you actually collect, that large chunk of data by itself cannot provide you so much insight as only two values, namely mean and standard deviation. You are able to arrive at that particular phenomenon in a very, very robust manner, fantastic manner. And once you have this mean from your data, and you have already set a hypothesis, that is, say for example, you have already projected a certain other mean, then comparison of this mean, that mean with this can be accomplished with the help of Z test or T test, depending on whether you know the standard deviation of population or you do not know the standard deviation of the population. I hope I'm able to communicate my point, my dear friends. Is my point clear? Can I have a few yeses or no's here? Am I able to communicate my limited point that I have made here? Dear friends, can I have it in the chat box? Your yeses? We have 155 people sitting here, and I hope a large number of them are definitely listening. Because, it is very interesting these days that we do not really know, very, very often. It is very human, but interesting also. We log in and then we, you know what we do. We humans. Fine. Okay, thank you very much. Thank you, Mr. Tabriz. Thanks, Mr. Prakaparesh Thakur. Thank you, Rama Mittal. Yes, Mr. Rakesh Kumar. Thanks a lot, Rakesh Kumar Patel. And Shehnaz Mansoori. Thank you very much, Dr. Jayashri. Very fine. Okay, I'm satisfied. Fine, my dear friends. Now here, in the univariate area, thank you very much. It's fine. I'm satisfied with your responses. Thank you very much for being so kind in sharing this, your yeses with me. So this is one aspect. The reductionist aspect is, please remember, respect. Normally what happens, the descriptive analysis that we get. I've seen my PhD students, researchers who have been working with me, or when I was a student myself, I would be very eager to analyze my regression results or multiple regression results or factor analysis and structural regression analysis, etc., multivariate tools. I would very much like to jump to that. And my students also show that tendency of jumping to that, ignoring the descriptive analysis. But univariate analysis can give you substantial insight. We need to learn to respect it. Why? Few pieces of statistics provides you huge insight. Now, one more thing I would like to share here. Again, I'm sharing my screen with you. One more piece of information I want to share with you. And then I will come to the bivariate analysis very quickly. Look at this. We all know, we study the peakedness of the data. We have three type of distributions. Please forgive me forgive my poor drawings here. Just a moment. Let me just see if I can make a proper one here. See, say peakedness. This is one distribution that you have. This is, say this is another distribution that you have. Assuming they all have the same mean. Sorry. This is a straight line I'm trying to draw here. Please forgive me for my bad drawing here. And the third one is, say, this is the mesokurtic or normal distribution. Now, this distribution is highly peaked. This one is, we will say, flat. And this is our mesokurtic distribution. Okay. Now, please see. If you employ this area property of normal distribution, that x bar plus minus, or say we happen to know the population mean, and then sample mean, or allow me to use, okay, same thing, plus minus 3 standard deviation. Now you can see here, if your distribution is highly peaked, all right, it is normal. We always undertake the normality test for our data. When it is ratio level data, we often undertake normality test. But this normality test is undertaken, but often we ignore the peakedness. Why? Because here standard deviation of this particular distribution, this one, and the standard deviation is very large. So your mean will lie, that is the range of 99% of the observations lying, that will be very large. But the range, mean plus minus 3 standard deviation in case of peakedness, is going to be very small. And here we say, okay, acceptable. All right, that is there definitely with all of us. We do that. But this particular point must be a part of your analysis when you are making the analysis of a single variable, my dear friends. So in the univariate analysis, this needs to be paid attention to when you are describing your variable. And number two, if you are doing the hypothesis testing or relating to mean or any other variable for that matter, whether you are employing the z-test or you are employing the t-test or you are employing the comparative tests of the two means, the peakedness of the two variables must be kept in mind, and whatever results you obtain, they should be analyzed in the light of the peakedness of the variable or variables. This is what I wanted to highlight, my dear friends, as far as the univariate analysis is concerned. I hope this is fine. Now, since my lecture has to end at 5 o'clock, I shall like to move to the second variable now, second aspect of my lecture, and that is, we will take the questions later on. Kindly note down your questions, whatever queries you might have, dear friends. We shall take up the questions later on. I shall move now to the bivariate analysis. That is analysis of two variables. Now, only two things come to the mind here in this regard. And what are those two things? Two things are the root of what I will call axiomatic deductive mathematical approach. See the phrase I'm using. Root, the foundation of axiomatic deductive statistical approach that we have. The approach that we have, whatever approach we have now for the analysis of data, that approach is at philosophical level. In terms of philosophy, if I have to describe this, we call it axiomatic deductive approach to statistics and mathematics, or mathematics and statistics. I'll explain to you that just now. In this approach, the analysis rests on one thing, one statistic, most important statistic, and that is called correlation. Even regression is dependent on correlation. Now let us look at correlation, regression, and what I have just now spoken, the phrase axiomatic deductive approach. Now, for a minute, to understand this correlation, I shall like to go visit once again the formula of correlation. What is the formula for correlation, my dear friends? If I describe it as rho of yx, two variables yx, what is correlation? Correlation is, I would like to describe it, how two variables move together. Divided by how two variables move separately. This is what we say, how they move together. We simply say covariance. Covariance. That is, they vary together. Covary. Covariance yx divided by how they move separately. We will say standard deviation of x and standard deviation, or standard deviation of y and standard deviation of x. And what is, how do they co-vary? Vary. Word is covariance. So word is vary. And we add to that word co-vary. And that we divide by standard deviation y and standard deviation x. So let us look at what do we mean by word vary. Vary is variation. Variation is, what is variation? Variation is variation. Remember now, I took this example, data set 3, 6, 9. And I reduced these data points in my previous example to only one value, 6. I hope you're paying attention, my dear friends. I need your attention very strongly. And if you're taking notes, please do take notes. They co-vary. How do they co-vary? First, let us understand the meaning of the word vary. What is vary? Vary is variation. What is variation? Variation around mean. So this is what variation is. Variation around mean. Now look at this. This covariance. Co-vary. What is co-vary? Variation. Co-vary. Variation around mean. Variation around mean of y. One variable. Covary means variation around mean of y and variation around mean of x. Well, divided by standard deviation y multiplied by standard deviation of x. Now please see, covary is what? Variation of y and variation of x. What is variation of y? Variation around mean of y. See this example I gave you here. These values can be replaced by 6, 6, 6, 6. So we need to know the variation. For knowing how do we calculate variation? Variation is actually 3 minus 6, 6 minus 6, 9 minus 6. This is what variation is. Although total is 0, but this is what variation is. So variation is around mean. Why variation around mean? Because mean is replacing all the values. I hope I am able to make myself clear. So now, given this, what is correlation? Correlation is covariance divided by standard deviation by standard deviation x. Covariation is co-vary, varying together of y and x. What is varying together of y and x? Variation of y around its mean and variation of x around mean. So what is variation of x around mean? This is, we say x minus x bar or xi minus x bar, and this and is nothing but multiplication. Yi minus, sorry, ulta likh diya maine. I should write like this. Yi minus y bar multiplied by xi minus x bar and their multiplication, and we sum this whole up and we divide it by standard deviation x and standard deviation y, my dear friends. And this gives us correlation of y and x. Now, please see here. Correlation is dependent on nothing but variations. Variations of X, variations of Y. And in terms of thought process, if you look at this type implementing this particular formula, covariance is, very interestingly, covariance is this. And we can say on the basis of this that covariance of X and Y and X is nothing but correlation of Y and X multiplied by standard deviation of Y and standard deviation of X. This is very interesting thing, my dear friends, about here. Please note one thing here. That the whole, and I'm talking about Carl Pearson's formula, my dear friends here. That the whole exercise of bivariate analysis rests on correlation. Now here, my dear friends, when we are talking, I'll link it straight now to the axiomatic deductive approach also in a short while from now. And also I shall link it to the study of regression analysis. Now please see, this particular formula makes certain assumptions and it has certain features. And what are those assumptions? Those assumptions have to be kept in mind. And I will like to take up two of these assumptions, two of assumptions and one feature. First assumption is assumption of linearity. Second is assumption of normality. And then there is a feature as a result of this. The feature is feature of sensitivity. Now I shall discuss this feature and this condition. This is condition and this is a consequence actually. This is consequence and this is a condition. Now let us talk of the linearity. Now what does linearity really mean and what implication does linearity have from our point of view? And what the condition of normality, what condition does normality have from our point of view? And then we shall take the whole data, whole analysis over to the regression analysis and discuss certain aspects. And from there, I will move to my last part of the lecture, that is multivariate analysis. Now, dear friends, here, there is, as I said to you, essentially, we are following an approach, positivist approach. Positivist approach is that the phenomena that you are studying, that is observable, measurable, there is a distance between observer and observer. And there is an assumption about the universe. Is Brahmandika, entire universe, the phenomena. We make a few assumptions about it. And what are those assumptions? There are actually, at philosophical level, there are two schools of thought. One I will call the axiomatic deductive approach, which I spoke just now. The word I had used, I'll explain to you just now. And second is what I will call the Socratic approach, the approach given by Socrates. First, let us look at the axiomatic deductive approach. Axiomatic deductive approach says, this was actually the origins of this lie in the thinking of Galileo. Galileo started that particular thought. It was Galileo who said that the phenomena can be described in terms of four things only. And what are those four things? The four things are shape, size, location, and motion. Shape, size, location, and motion. I repeat, shape, size, location, and motion. And all of these four are measurable. He denies completely, Galileo. Completely, he says that the five senses, sound, watching, seeing, smell, listening, talking, he says these are matters of soul and they are not measurable. What cannot be measured cannot be studied because it is a matter of soul. He says falling of a tree makes vibrations, can be measured. But the sound that it makes, that sound is heard when a human being is present there. That sound does not exist if the human being is not there. And therefore, Galileo said that the universe can be studied. Universe is written in the language of mathematics. It can be described only in mathematical terms because he completely rejected the idea of the role of senses in the study of phenomena. Okay? Now, this school of thought, this idea was further explained by Descartes. Descartes is the spelling of the name of the philosopher. Aristotle, as we call it. Aristotle and Descartes. Aristotle and then Descartes in the modern philosophy. So there, this school of thought makes certain assumptions about us humans, about the universe. That number one, universe is a fixed and given quantity. First. Second assumption is, very important assumption, man is an animal, although a social animal. And number three, best application of energy takes place in the linear form. Very important assumption. Best application of energy takes place in a linear form. Energy gets best concentrated when applied linearly. For example, if you have a loaf of bread in front of you and you have to break it, if you break it just like that with the power of your hands, then the breaking would be uneven. But if you break it with the help of a concentrated application of energy of a knife, then energy is best applied linearly and it is a very efficient application of energy and therefore it is neatly, nicely and articulately cut. Similarly, they say that all phenomena, ultimately, all phenomena are forms of energy. Energy is best applied, efficiently applied when applied linearly. Therefore, all phenomena move linearly. And when you apply this concept to the social science, study of social phenomena, psychological phenomena, anthropological phenomena, human phenomena, when you apply it to that, so we say all phenomena will eventually converge linearly in the long run, very long run. So if you are studying relationship between interpersonal trust and performance, so you will say eventually trust will be able to predict performance linearly. So we study it in terms of linearity. I hope I have made my point clear. This point becomes clear to you. It is from these philosophical points that the idea of linearity, my dear friends, comes out. I hope I'm able to explain. Some people are asking SPSS, etc. We'll discuss this later I hope is my philosophical point that I'm making about why we assume linearity. Is this point clear, my dear friends? I just want to hear a yes from some of you. Please don't talk about SPSS and other things like this. That is a different thing altogether. I am talking from the, when you talk of the bivariate analysis, philosophical standpoint of it, SPSS is available to you. But this philosophical explanation I wanted to make at my, as my, what you will call in management, we have marketing thoughts. You call it a unique selling proposition. I am not being practical. Mr. Lal Bihari Barik is saying, be practical, sir. No, dear friend. I am addressing the academics. Practical application will take place undoubtedly. You have data, you feed it into the computer, but why are you doing it like that? As an academic, I think you should understand and appreciate the philosophical foundations of what you are doing. This is very much required. Thank you very much, Ms. Nimisha Gadaria, for agreeing with me. I'm again saying that this philosophical dimension has to be understood very, very clearly, my dear friends, that okay, Mr. Mrinal Joshi, Dr. Mrinal Joshi, difficult, but trying my best to understand. Let me explain once again to you. The idea is that when we are talking about measuring a phenomenon, say, for example, you are studying relationship between motivation and performance. You are studying, say, relationship between interpersonal trust and performance. You are trying to study the dynamics of role of envy, for example, in an organization, in a business organization. Say you are studying, you define your phenomena. Now, when you are studying a particular phenomena, then tools have been developed to study these phenomena, like correlation and bivariate analysis. Why this correlation has been developed with the assumption of linearity only? Then we have to look at the assumption, understanding about the nature of phenomenon, Dr. Mrinal. What is the assumption that we are making about the phenomenon, about the entire universe? The assumption here, Dr. Joshi, is that all phenomena are essentially expressions of energy, and energy is best applied linearly. So if we have to measure the phenomena, we must measure it in a manner that assumes or leads us to, please underline, that assumes or leads us to linearity. Therefore, this formula that I showed to you just now, that you know already, I'm sure you know, that assumes linearity, my dear friends. So this is what essentially is. And when you gather the data, we categorize it for analysis purposes. When we categorize it, at that moment, when we classify, not categorize, I'm sorry, the use of the word should be that we classify it for the sake of simplicity. That is the first thing that was taught to us in class 8. We were asked to make the frequency distributions. That is the first step toward organizing the data. So why do we organize it in the manner in which we do? We organize it. And based on these organizations, we say that some of the organizations of data are universal. They are applicable to large number of variables. Large number of variables, my dear friends. And we say what comes up is that variables follow normal distribution. That is, when we classify them, the shape that they take is bell-shaped. And we make a theoretical distribution called normal distribution. Dr. Lal Bihari Barik is asking, how will you decide threshold value? when we are going to find correlation between variables. I'll take it up later on. Basic point, please try to understand, Mr. Barik, what I'm trying to say here. Threshold level is not important. Please understand what I'm trying to communicate. I'm not talking of that at all. I'm talking of the foundation of the correlational analysis. The foundation of correlation analysis is linearity. We are assuming that phenomena will fall correlation. And as far as the threshold are concerned, there are rules of thumb. I'm not talking about that, Mr. Lal Bihari Barik. I can see in the chat box, you are asking for decide threshold. I'm sure you are talking about threshold. This is typing mistake. So I'm not talking about that at all. Please understand the nature that I'm trying to make you understand about these thresholds are available in the textbooks. The thresholds are not important, or if they are important for you, look at it in the textbook. But here, I'm talking about the nature of correlation, my dear friends. And the nature of correlation, as I say, rests on linearity because we assume all phenomena will essentially be linear. They will be on a straight line. And second aspect here is when you are using correlation, then be very careful about it. It is Carl Pearson's method of correlation analysis is very sensitive. What does it mean? I'll put it like this. Say, for example, I say calculate correlation between these 4 values. This is Y and this is X. Obviously, from here, we can very simply say here that the correlation here would be 0. If you have this kind of data, correlation would be 0. But if I add these 3 values also to this, that is, if I take correlation of only these 4, the correlation would be 0. But if I take up the correlation of this entire data set, my dear friends, this entire data set, or I would rather say, then correlation will not be, you will find it will be moderate, say around 0.3 or so, the correlation. That means what extreme values will affect your data. If you are doing the bivariate analysis, then therefore, my dear friends, the outlier analysis becomes very, very important for you. So if you want to do the bivariate analysis, my dear friends, then in this exercise, we must pay attention to the extreme values. Otherwise, your correlation will get severely affected adversely. And when we go to the regression analysis, my dear friends, Professor Viral Arora has asked a question here. Professor Viral Arora is asking a question. He's saying, is it necessary to check normality when we have very large data? Yes, it is very necessary. Professor Viral, I'll come back to this point once again later. But for the time being, let me proceed on. Now, please notice, your correlation becomes highly sensitive. All right. And now notice one thing. When we go over to the next aspect of the exercise, that is the second tool that we make use of, that is, say, regression. If you look at regression, then what do we do in regression? In regression, we say these are our original data. These are our original data. And what we do, regression, we try to find out some values based on the relationship. What is regression? Regression is based on observed values of two variables. We find such estimated values, which fall on a straight line. This is what regression is. You have these values which are in blue color, and based on the relationship between these observed values, you arrive at certain, look at these values in red. You arrive at distinct values for given x values which fall on a straight line. So assume that it is a straight line, my dear friends. This is what regression analysis is. And we get the slope of this. And how do we do it? We do it by employing this equation, y hat is equal to alpha plus beta x. And how do we arrive at beta, which is the slope? Beta is nothing but covariance yx divided by variance of x. Or covariance, we know, we saw it in the previous line. Covariance is nothing but correlation yx multiplied by standard deviation of y, standard deviation of x, divided by variance of x. And if variance of x is nothing but, we can further write it as correlation yx multiplied by standard deviation y, standard deviation x, divided by standard deviation x multiplied by standard deviation y. This xx gets cancelled, and we are left with correlation yx multiplied by ratio of standard deviation of y and standard deviation of x. Now please notice that entire regression analysis is based on, again, correlation and standard deviation. So this correlation affects your beta. That is, the relationship between y and x is captured with the help of beta, with the help of slope. And mind you, the alpha that you calculate here, the intercept, that is y bar minus beta x bar. Again, it is dependent on beta. Whether it is your intercept in this regression line here, or it is the slope. The basic aspect, the regression line that you have, the entire regression line, my dear friends, rests on the thought or idea of correlation. And correlation is linear. Correlation is sensitive to extreme values. And this must be constantly at the back of your mind when you are making the bivariate analysis, my dear friends. I hope the small limited point that I could make in this small limited time period, that is clear. From here, I shall, my dear friends, like to move to, thank you, Dr. Parish Thakur. Now take up the question. Before I go to the third aspect, the question the point that has been raised by Professor Viral Arora. He asks, is it necessary to chalk normality when we have a very large data, maybe more than 500, 600? I would advise that please do that. Otherwise, with large data, it is not required very often. But sometimes, we do come across data which may be lopsided. Normally, it would not be, but sometimes, if the data is convenience data, or the data collected is not very random, the data is convenience data. The data is, say it is purposive data, or you create strata in the data yourself, then sometimes it becomes dangerous. Otherwise, it is not required. Even if 500, 600, it is not required. So you will have to take a look at the method you have adopted, Dr. Paresh, Dr. Viral Arora. Please pay attention to the manner in which you have gathered the data. Have you created the strata within the data collection at different levels? For example, we are studying, say, the relationship between performance and incivility. Say, you are studying that. Now, you collect data. Let us collect data from the workers, from the supervisors, from middle management, for top management. Now you have created strata. Now here strata are created which are comprehensive. So here you would not require to carry out the normality test when your respondents are 500 to 600. But if you say, I would like to study only the top executives, then there may be, if you want to make generalizations about the executives in general, then normality must be tested. This is what, my dear friend, I would like to suggest. Okay, now let us move after this, my dear friends, to the multivariate data analysis. Now here, as far as multivariate data analysis are concerned, I would talk about, now here, my dear friends, I think, am I audible, sir? My screen sharing is good.
Yes.
I have not stopped.
Yes. Yes. Audible, sir, and screen is also visible.
Okay, thank you. Now, please see here. I am sure. Let me just take up this concept of variability once again. Please notice that when we do the analysis, the bivariate analysis, say we have these data with us, very small number of data points I'm taking, and you fit the regression based on alpha and beta, say these are the unique points that you have, and you have fitted the straight line to the data. Now here, we are interested in only one thing. When we are doing the regression, or where we are doing the regression analysis, then we are interested on one very important thing. Important thing is how much variation in Y is explained by variation in X. This is our primary concern. And second primary concern here is the relationship between Y and X significant? Now here, very often in research, what we do, that we focus on this particular aspect. We look at the test of significance of beta. That is what we do. And we very often ignore this particular aspect. How much variation in Y, is explained by variation in X. This is a very important factor. So let us understand variation in Y. What is variation in Y? Variation in Y is, we know, variation is variation around mean. So there are two things that we are concerned with here. Variation in Y and variation due to variation in Y, due to variation in Y, called explained by. Explained by means caused by, and the causal relationship is done by us theoretically. Variation by is explained by variation in X. So variation in Y, and second aspect is variation in Y explained by X, or I would rather say variation in Y, variation in Y due to X, due to variation in X. These are two things. And what is variation in Y? It is Y minus Y bar. And since sum of the deviations from Y minus Y bar is 0, we square it and we take the total of this. Look at this diagram. Here, let us put a Y bar here. Y bar, mean of Y will come here, and this will remain constant with the X. So Y minus Y bar is this. This is Y, this is our Y, and this is, sorry, this is from Y minus Y bar. That is, look at the screen, please. Please focus on the screen on your laptops. This is Y. From Y, look at the movement of the dot. This is Y. This is Y. That is the hard line and the bold line. This is Y. From this Y, we subtract Y bar. What is Y bar? Y bar is the green part. So we remove this. And Y minus, we are left with Y minus Y bar. So this is actually our Y minus Y bar. This is our total variation, variation in Y. And variation due to X. Now this Y hat, as you call it, this Y hat, say this is the Y hat. This Y hat has come from this equation, alpha plus beta X. This Y hat has come from regression line. Regression line has come from relationship between Y and X. This Y hat has come from relationship between Y minus Y bar. Okay, so variation in this will be Y hat minus Y bar. Again, we square it up. And now see, please. We can see here the total variation. Total variation is Y minus Y bar whole square, and variation due to X is this, Y hat minus Y bar whole square. And the ratio of the two, if we divide this with this, we call it explained variation divided by total variation. So this actually becomes our R square, which you call coefficient of determination. How much of variation in Y is explained by variation in X is given by R square. And this R square is ratio of explained variation divided by total variation. I'm just putting hat here. I hope, I'm sure you know it already. I'm sure all of you know it, my dear friends. This is clear to you. Now, please see. So there are two things, as I said just now to you. I stated to you just now that there are two things that we need to study. How much variation in Y is caused by, explained by X. This variation is nothing but the ratio of explained variation to total variation. And we do it with the help of R square. This R square is very, very important, my dear friends, in your analysis. This must be paid attention to. Normally, what we do is we focus mostly on the second aspect, that is the beta, significance of beta, and we tend to ignore it. If you are making the bivariate analysis, please do pay attention to this aspect. As I would say, if you have two variables, Valentine's, if I say this is Y and this is X, this is R square. If it is say 0.25, which means R would be equal to 0.5. And this is 0.75 and this is 0.75. Unexplained variable is, variation is 75%. I hope I am making this particular point clear to you. I hope my idea has limited point. I have made limited point. And can I have your yeses once again, my dear friends, about this? Then I'll quickly go over to the multivariate analysis. Please come in your chat boxes, my dear friends. I just want to see some yeses. If you please are generous enough to give that to me quickly. Yes, please. Very clear. Thank you. Bhavna Patel ji, thank you very much. Dr. Khatri, Dr. Hemraj Singh, Rama Mittal, Jai Shri Narang, thank you very much. Very fine. I'm quite happy. Kiran S. Prajapati, thank you so much. Balwant Kumar, thank you. Okay, can I have a few more? I've got only 10, 15. Why not more? Please. Excellent. Okay. Thank you, Dr. Viral. Jayesh, nice. Subhash Bhosle. Yes, right. Okay, fine. All right. Mehul Shah, Dr. Shah, thank you very much. Fine now. Now, after this, let me go to the multivariate analysis. Now, again, in multivariate analysis, since time is very short, I would like to speak in terms of the semi-partial correlations and partial correlations. Again, these semi-partial correlations and partial correlations are ignored by us. But if you pay attention to semi-partial correlations and partial correlations in multivariate analysis, then you can arrive at very, very powerful conclusions in your analysis. Since time is short, I'll come straight without going anywhere into the detail. Let me come here. It's here, my dear friends. Say, for example, you are studying three variables. Say this is your Y. And this is your X1. Multivariate analysis means more than two variables. And this is your X2. All right. Assume that all the three circles are equal. Okay. So now we have Y, we have X1, and we have X2, my dear friends, in the multivariate analysis. And let us, my dear friends, present these ideas in this manner. Let me call this Shall I continue or Dr. Shah? Is it okay for me to continue or I should?
Yes,
Because it is
yes,
seven
sir. Yes,
minutes to
yes, sir.
7 minutes
Okay.
to 5. I may have to exceed the time. Let us ask the participants. Are they fine with it if I take 10-15 minutes more?
Yes, participants, you can write down in
Please
the
give
chat
your
box,
opinion.
please.
Either we
If you are
stop here
interested, please.
or we spend about 10-15 minutes more over and above 5 o'clock. So please tell me. Kindly, my dear friends. All right.
Yes, sir.
Fine.
Participants are interested, please. Yes, sir.
It's fine. Okay. Come here. Now, I will put it in this way, my dear friends. एक बड़ा simple सा बात है. Multiple correlation is here. I'll put it like this. Some subscripts I'm putting A. This I'm putting here. So no. Let me just change it. I will call this A. Let me call this no, this is actually wrong. I'll put it in this way. Just a minute. थोड़ा दोबारा मैं इसको ड्रॉ करता हूँ bigger one so that we are becoming clear. Just a moment. This is our Y. This is our X1. And this is our X2. These are the variables. Now we are studying the relationship between Y and two independent variables, IVs, X1 and X2. Now how we can really study these variables? Let us call this A. Let us call this B. Let us call this C. And let us call this E. Simply. This is more confusing. I'll put it E. Now please see. What is A? What is, let us look at three values, A plus C. What is A plus C? A plus C is correlation of Y with X1. It is simple correlation. A plus C is this. And B plus C is nothing but correlation of Y with our second variable X2. And we will say A plus B plus C is, I'm changing the subscript, it is, sorry, R square. It is, I'm using the phrase R square because it is multiple, more than 2. R square, variation explained by, variation in Y explained by 1 and 2. Variation in Y explained by X1 and X2. Please note this down. It is very, very simple. Understand the concept. What is R square Y1? Variation in Y explained by X1. Variation in Y here. Variation in Y explained by, that is these two here. Please note that. Now here, I'll remove these arrows later on. Look at this red color. It is this portion. I'm sorry. This portion. This is A plus C. And here, it is B plus C, this portion. Right? Very interesting. This is very interesting. Now, let me remove these red lines here. And let us focus. Now, please see. If we look at these three, A, B, C, then we are able to understand what is role of X1 and X2 in Y. But look at this. Let me look at only A. Only A. Then what am I getting? Green portion. Or let me look at only B. Only B. This portion. If I look at only this, this can be called semi-partial correlation. I will call it I'm sorry. This is semi-partial correlation, and this is nothing. If I call it 1, allow me to call it 1, then this is nothing but total variation in Y explained by Y12. Look at this, ABC. This is minus R square Y2. There is something, just a minute, please. The variation explained by Y2 and B is nothing but semi-partial correlation. Of course, in terms of squares, 2 is equal to total variation in Y caused by 1 and 2 minus the variation explained by. This is a very powerful explanation, my dear friends. I don't know whether SPSS or eViews provides this or not. Normally what I do is that I calculate it on Excel by simple formulas. And the simple formula is, this is squared. I do not square it. I simply say, I will calculate SR1 with the help of correlation of YN1 minus correlation of Y2 multiplied by correlation of 1, 2 whole divided by under root of 1 minus R square 1, 2. You can calculate this with the help of Excel. And obviously, semi-partial R2 would be R YN2 minus R Y1 R12. You can see there is a pattern divided by whole root of 1 minus R square 1, 2. Very simple. You can extend it to n variables. I don't bother about SPSS. I prefer to calculate it all by myself. And multiple R square is given by Excel also. Everybody gives that. Otherwise, you can have the formula, and I'll recommend a book to you, my dear friends, for this. The book by Cohen, West, and Aiken. There are 4 authors. Originally, this book had come from Cohen and Cohen only, but later on, these 2 authors were added, AIKEN, and the title of the book is Multiple Applied, little long title, multiple regression slash correlation, little long title, applied multiple regression slash correlation analysis for behavioral sciences. It's a fantastic book and it gives you a lot of insight into this. Now, from here, एक और चीज देखिए आप. Now, this A, if you are able to calculate, it gives you exclusive role of X1 in Y. B gives you exclusive role of Y X2 in Y. It is a very powerful explanation, my dear friends, particularly for policy making. So this is one thing. और एक चीज देखिए यहां पर, और एक पार्शियल कोरिलेशन हम कैलकुलेट कर सकते हैं. देखिए कैसे. Just note partial correlation. Note that partial. This was semi-partial. I'll just wind up in 5 minutes. I know you've been listening to me for a long time, but I think this will serve the purpose. Partial correlation. It is very interesting. This is, we will say P, or I'll say small p, PR1, partial correlation number 1. 1 means X1. Correlation of 1 is actually A divided by A plus E. And second partial correlation is B upon B plus E. See this. What is the role of X1? What is the role of X1? Or X2? What is the role of X2? In. Now see this. How much of variation is explained by X2 when we include the variation of this variation of X1 and unexplained. This and this. Please note that. Look at this. It's a very interesting analysis. E is neither explained by X1 nor explained by X2. So, what is the, see this, it means this E is explained by those variables which are not included in your equation. This is the residual. Residual plus B. What is the portion of, what is the explanation by X1 out of what? All unstudied variables and your variable. All studied variables and X2. That is partial correlation 2. All studied explanation by variation by unstudied variables, unknown variables, and known variable X2. Similarly, partial correlation number 1. Role of X1 in unknown variables and X1. Role of X1 in unknown variables and X1. What a powerful explanation do you get out of this. And once again, there is a very simple formula that you can utilize here. You calculate the multiple correlation between Y and this minus R square of Y2 divided by 1 minus R square Y2. This is your partial correlation number 1. And partial correlation number 2 is R square Y and 1, 2. Multiple correlation, squared of course. R square Y1 divided by 1 minus R square Y1. So simple, my dear friends. And this gives you huge insight into the analysis. Of course, there are other aspects of the multivariate analysis which should cover which should be covered in multivariate analysis, such as factor analysis, the structural equation, the structural equation modeling, such as the grouping analysis of different type, but the time does not permit. I have only in multivariate analysis given you insight, tried to give you insight into the study of semi-partial correlations and partial correlations, which gives you huge insight into the study of phenomena. Yes, stepwise regression is also very important. Backward, forward, can you discuss in short? Well, I would not advise you to take up, Lal Bihari Barik is talking about stepwise regression. I would not advise you to take it up because the results of stepwise regressions are never substantive. They are always tentative, my dear friends. And when we do the stepwise regression, then, the computer randomly selects the variables, whether it is forward elimination or backward elimination. What is the elimination? आप देखिए elimination क्या है? Dr. Barik's question, he is asking me to describe it shortly. हम ऐसे करते हैं. Let me share the screen once again and go to my Valentine. What is this? Variation in y explained by x and y. So first we take up the variable which explains maximum variation in y. Then we eliminate that variation. Whatever is left, say for example, here. Say for example, we have y, x1 and x2. Now we can see here a large x1 explains only this much variation, shaded in red color. And x2 is explaining the portion x2 is explaining blue portion. Now blue portion is more. So what we do in stepwise regression, that we first try to identify that variable which explains maximum variation in y. All right. And we eliminate this variation caused by it. And whatever is left, out of that left out, how much is explained by x2? So x2 will give us this portion. Please notice it. All right. This is how stepwise regression goes on. But the coefficient calculation method is such, particularly when there are more than two variables, that the regression coefficients are not substantive. They are very tentative. So they cannot be used for predictive purposes. And the standard errors of stepwise regression coefficients are larger than otherwise. So be very careful while using it. And this is what I have done just now, that the largest variable, when you believe this is forward elimination. Backward elimination is that first you eliminate those which have a smaller explanation, and then you proceed further. Tabriz is saying, do you have Excel sheet for semi-partial or correlation, partial correlation? I will check, sir. If it is available, I'll give it to you. Normally, students, I teach my students and they create the Excels. If I have one, I'll try to mail it to you. I don't promise. If you have any other question, please answer. Please ask. Yes, please. So with this, my dear friends, thank you very much. You have been very nice and cooperative audience, my dear friends. Thank you very much for this. And I thank the business school which has invited me today here. Very nice of you. And please convey my thanks to Dr. Bhavesh, who took the trouble of inviting me and deliver the lecture to your institution, Amroli College. And it is a great effort that you people are making by involving the audience all across the country as well as across the world. And you are making great contribution towards the cause of academics by undertaking this kind of workshops. Thank you very much. Thanks a lot.
Okay. Thank you, sir. On behalf of all the participants, I would like to say thank you. And I would like one sentence, sir, please. For each and every question from the participant you have taken, it is very easy to explain. You have explained in a very easy manner. For each and every question, you have opened a digital paper on the screen and give the answer with the digital pen. That is more informative to all the participants. You have explained all the answer with a simple manner. Okay, and at last, I would like to share. Raj Dumasia sir. Raj Dumasia sir is here.
1 minute, sir. 1 minute. There is
Yes, sir.
there is Mr. Tabrez who is asking a question here.
Yes.
Suppose we have dependent variable like COVID-19 mortality rate, and we want to test with respect to country characteristics, low, medium, high income level, using linear and multiple regression. So your dependent variable is mortality rate. So your mortality rate will be is a variable which is actually a ratio level variable, and your independent variable is low, medium, high income level, which means it is ordinal level. So you are regressing, Mr. Tabrez. A ratio level variable is your regressand, and your regressor is ordinal level. Well, you can do it. You can take variable as 1, 2, 3 if you want to. But once again, and your data will be, whether it will be panel data or not, if you can somehow obtain the GDPs, that is ratio level as dependent variable and ratio level as independent variable, then I think your result could perhaps be better. So you have to try. And there is something called threshold auto-regression, TAR, that you can make use of here. If you want to study the mortality rate within this, because mortality itself is affecting mortality in the COVID-19, if you look at the literature available. So don't try to establish just simple correlations, my dear. Okay. Nonetheless, some insight you can definitely obtain. और मुझे लगता है कि आप इसमें अगर frequency distribution बना लेना and apply the chi-square test, that would give you a better result. Because you will have converted all the data into the categorical data. So perhaps, I'm not saying this is definite answer, that could be a better way of looking at it. I hope I have answered your question, Mr. Tabrez. Yes, please go on, sir. Yes, sir.
Yes, Raj Dumasia sir is present here over here. Raj sir.
Yes, sir. Yes.
Yes.
Namaste. Good evening, Honorable Speaker, sir, respected Principal, sir, and all the participants. First of all, I would like to thank our visionary Principal of in charge, Dr. Rajeshri Rana, sir, who gave me this opportunity to speak on this research session. It is a matter of honor for me. On the behalf of entire institute, I would like to thank Dr. C.S. Sarma, sir, who gave us his precious time and very informative session. Thanking you, sir, from bottom of my heart. I also express my gratitude to all the participants who are joined in this session, because your participation and your suggestion always help us. And last but not the least, I would also like to thank organizing committee and technical team. Thank you. Jai Hind.
Thank you very much. Thanks a lot, really. It is very nice. Your audience was good and your organization was very good. And I would like to express my gratitude as almost my best wishes to the JZ Shah Arts College. And this is your JZ Shah Arts and HP Desai Commerce College, I think. Amroli. Am I right? Oh, am I?
Yes, sir. Yes, sir.
Very nice. It's a great effort that you are making and making a good contribution to the cause of academic growth and development of the academic community. And thank you very much for inviting me. I'm feeling very elated and happy about it. And we do hope that in future, if there are any endeavors, we shall like to meet again. Thank you very much.